So, this is already seen. So, I am just quick just to warm up kind of a thing. The first over, I think matches also started, okay. So, this first over it is. So, the important point is, if you are a technology development company and therefore you are an employee of that company, one thing we have to be very clear is, what is the area of research we are going to work on should be chosen with a lot of care. Obvious point, but why I say this is because in academic, typically how the research take place. Let us contrast with that, which is probably you are more familiar. This happens here, a particular faculty member, for historical reasons he is interested in one area of research. If you ask him, why are you interested in this area of research, he will say his guide, his PhD days, whatever. So, it will go back to some. So, therefore, it is starting from somebody who is wanting to take up a topic and then understand more about it. So, that is how in academia you just freely choose your topic, and after some years you can switch the topic also, okay, no problem. In fact, most of the people switch, excepting this guy in MIT who I talked about, who is wanting to work on steel by electrolysis, he is at it for the last 25 years. So, most of the time in academia, the area of research you choose what is interest to you at that point of time. Switch to technology development companies, they do not do it in a random manner, they have to take a very conscious decision of why they want to work on that, and the principles are very easy. You work on an area where there is a lot of potential, is not it? Is there any other way? That is it. But to actually figure out what is that there is got potential, and therefore you should spend time, is a very deep process. So, therefore, people choose a lot of care on that. They knowingly, because first of all it takes long time, the probability of failure is very high, and even if you technically succeed, that it will actually be making money in terms of product is also suspect. So, keeping all this in mind, still people choose. So, that is the first point which we should keep it in mind. Then the connection between research and you get an idea, something new that you want to do, and then you know this is like the caterpillar, crude, vague, broad. Then the butterfly which comes out after some metamorphosis is what the technology is. So, this should not happen by chance, and even in nature it does not happen by chance, okay. So, this is what we have to, the guys who are working in technology area, they think through, and that is why I mentioned the requirement for being very strong in your basic principles is the highest in technology development. Plus you must also be very, very sharp and shrewd to take a call on what is likely to happen in the future. It is said that forecasting is always difficult, and if you go back, there are so many forecasts are being made, including this current test match which is going to begin. It is only a 4-day or 5-day event. You make a forecast, and at the end of it you will know how much you have done it or not. So, forecast is fraught with a lot of, more so for a long period of time. So, therefore, the companies which enter into that is what they do. So, this is what it is. Now, the last part is, which is relevance to the next classes, is people have developed, because it is long drawn, complicated, difficult and so on, like if you have a scale of measurement which you can use it to say, okay, this is at what level of technology development, this idea what is it that it is possible. It is a qualitative thing, it is not like 0 degrees Kelvin is defined and therefore the temperature scale is defined absolutely precisely, it is not like that. It is some judgments about has been made. I will talk about it in the next class. So, that is something which we should keep it in mind for research. Now, lot of good news or bad news depending on the way you see it. We started with manufacturing companies, right. So, most manufacturing companies, whether it is in India or outside, they do not engage in applied research either, forget fundamental research, they do not. But the biggest advantage that they have is that they are actually facing reality as it happens, in terms of what works, what does not work, what are the changing situations economically, competition wise. They are in a very good position to tell you what probably ought to be done, the requirements, probably what should be a different way of doing it. The essentials of what is needed they are in a very good position to sense, because they are doing it, they are sensing it in every day. This is an important point, because if you go to a researcher, every researcher thinks that whatever he is working on is the world's most important topic. Have you found anybody who says, I just picked up a research project, acha hai, theek hai? Oh, everybody is committed. But to give that contrast only, if you go to manufacturing, they are sitting there facing life with competition, with quarterly statements, with profit and loss and whatever you have got. So, while they may not actually be engaging in any research, even applied research, in fact most of them do not, they have a fund of knowledge, experience, information which can give you enough inputs to look at what ought to be done in terms of research. That is one thing. The second reason why they find it is, first of all, they are too busy doing whatever they are. Secondly, I think they would prefer to buy technology wherever it is possible. Makes sense, right? If something is available for a fair price, you will go and buy it rather than starting from all over the place. What on the other hand, if some of you have gone through the previous lectures, I told you to take the balance sheet or annual reports of companies and then randomly spend time. It is a bulky document, all nicely spruced up to hype you into whatever, but if you go to the essentials and see, they will also say there is a column, in the last year this company spent so much rupees on research and development and kind of activities, it is all described. So, spend some time to read through that. What goes on in those companies as research and development is of course definitely not fundamental research, it is probably not even applied research, it is just that they have some product, they tweak it little bit here, little bit here, make it more interesting to the customers, whatever, that it is not a trivial activity. I am not saying that activity is bad and research and development is on some exalted, it is not like that, but what they call as R&D is probably such helping them to extend the product here and there and that sort of, and they also for that they are heavily reliant on third parties. In fact, that activities may not even take place within the company. Classic example is auto. The car makers hardly make a very few components of a car, probably all of you are aware, right. Almost all major components are bought out from somebody, you kind of assemble it together as per your thing and then put a name to that and advertise it and sell it, and that is it. In fact, after sale service is also third party. So, that is what is the reality of the industry. I have said this and spent some time on this, not to discourage what is happening in manufacturing or EPCM, but to say that that is a kind of an environment. The plus point is there is a huge amount of practically useful relevant information you can pick up to frame your R&D. If you are in a technology development area, one of those brave souls willing to spend long years and so on, you can take what I told you, what you have to work on is to be chosen. You do not do it in isolation, you interact with this ecosystem, apply your mind and then pick up the area. So, that is the connect between research, technology development, manufacturing. This is the manufacturing part. The EPCM companies, what is the role that they play in this technology research development is, as you know, these are the guys who actually build the plants. Finally, you go to somebody and say I want this plant to be built, they actually physically build it right from scratch, run the plant for some time and show it to you, it is actually working, hand it over to you. So, these guys they act as a go between manufacturing companies and also the technology development companies, because they are in touch with both. On the one hand, manufacturing companies problems, opportunities, everything they will be aware because they are their customers, right. EPCM companies customers are, so they to be successful they have to be very close to the customer, the usual management jargon, you have to be close to the customer, understand the customer requirements and all that truly. Plus they would also have little bit more expertise in their rank and file employees, because I told you in terms of the requirements, moderately if you are good in your subject you can get by in most of the manufacturing jobs, because you can always brush up and pick it up. But if you have to be in EPC you have to be a little bit more sharper, the pressure will be a little bit. So, as the scale is technology developers on this, manufacturing is here, these are the guys who act like a bridge in terms of collating, discussing, passing on information and things like that. Again, these companies obviously are very few in nature and I could not really think of any Indian large company, maybe I have missed out something else, if you think of, correct me. So, some names I have given. Haldor Topsoe is a Denmark based company, they have been big in various areas. They started off with conventional chemicals like methanol, ammonia and stuff. Now they are gradually shifting into renewables, because they are also, this is one of the good thing, they also clearly understand what is likely to be the future. Even though they are not a manufacturer, they believe that this green energy thing will come more and more important in the future. So, they are taking up a product development, basic R&D, their own R&D, they support R&D in academic institutions. They are also in touch with a lot of engineering EPCM companies worldwide, looking at the market, where we should go, where we should not go, like that. So, they are very good. The second name UOP is Universal Oil Products. So, they are also very big in hydrocarbon industries. Huntsman is in specialty chemicals, a variety of specialty chemicals they make. Shell, of course, all of us know. Shell again is normally associated with the conventional oil and gas, but now they are also, Shell is gradually trying to see whether if this market slowly reduces, or if it is not the future, if there is some other market which is the future, what we should do. Johnson Matthey is company I mentioned, they are specifically into catalysis, all kinds of catalysis. Their domain is catalyst, whatever that happens, so on and so forth. You can read up and find out. Now, sometimes what happens is, especially UOP, it is true, there are very smart, intelligent, motivated people, bunch of fellows, they gather together and start technology development. You will see, like in chemical plants, I said it requires a huge amount of money. So, unless you have that money, it is not advisable to even to think of setting up a plant. In fact, yesterday some student asked, what about small scale sector? So, I kind of said, So this is manufacturing. EPCM also you require, because you need to have large number of people employed, and therefore it is like Google's engineering, Google is EPCM, you must pay them well and keep them and all that. But for technology development companies, what you need is only sharp ideas and few people, and initially anyway you will be doing it only in a small scale. So, it does not require too much of money at all. Therefore, what happens is, smaller companies are typical of research and development and technology development. So, typically it happens, somebody who is motivated, interested, etc., goes and starts up and gets some funding from various people and brings it up to a level, and this is going to be related to the TRL of the next class. So, keep that in mind, this TRL business. So, they will bring it up to some level, after which one of those Haldor Topsoe, Huntsman, UOP will come, because they are all the time interacting with the entire system, and these are guys with billions of money. So, they will figure out, they are also, they are looking at market, they are looking at academia research, they are looking at EPCM company, they will also look at startups and figure out the startup and say, you have brought it up to this level, we think there is an interest in you, why do not you just become part of me? In other words, the startup company is merged along with a big company and becomes part of them, and whatever is the terms of, like, for your knowledge you get paid. That is also the way that technology development takes place. Okay. These companies have their own very specific R&D. In fact, they have global R&D centers at 2-3 places set up, and they do completely different set of R&D as opposed to what happens in an academic institution. The same equipment, same X-ray diffraction and say GCMS, everything is the same, but the approach is completely different for that. Okay. I said in an earlier slide, manufacturing companies generally prefer to buy technology if it is available, and rarely they get into developing their own technology. There is one case history of a company, I will come to the end, but it is a rarity, let us not discuss that. So, why is it so, we have to ask, because this is something frequently I have heard academic researchers bitterly complain. I am basically from the industry, right. So, you guys, the talk goes like this, you guys have no vision and always think of only money, profitability. Technology, research and development must be encouraged. So, I listen, yeah, it is a point of view, definitely, but the counter to that from these guys, I was part of that, is when you buy technology, I do it for a reason, right. I am not very smart probably, but I am not an idiot. I run chemical plants, I can't be an idiot. So, why I do that is, when I buy something for a fee, I pay a fee, I agree. It comes with guarantees on what it is supposed to do. This is a very important point. If you set up a plant which is, we agree that it takes huge amount of money. So, you are taking a lot of, remember those guys who provide you owners and loan providers and equity and liability, these guys have lot of expectation, they are going to put you under a screw press and press you. So, when you do this, you want whatever you spend money and then set up, it should start running in a fairly trouble free manner. You can't have headaches, I mean at least you must have minimum headaches. So, technology purchase is done because usually the terms of purchase is such that the output from the plant is guaranteed. What does it mean? If you buy a plant of methanol 3000 tons per day capacity, based on the technology and the know-how and whatever you build, the fellow will guarantee you, I will be with you and show it to you over a period of 120 hours, whatever it is, that the plant actually produced 3000 tons of methanol, here it is. So, you get guaranteed. Supposing it produces only 2470 at his cost, he is supposed to rectify it in order to bring it up to 3000 or pay you a very heavy damage. In case supposing he throws up, it comes to 22995, it never reaches 3000. The manufacturer also may say this 5 tons should leave it alone, but instead give me a money and I get on with it, at least it is running at 2995. So, it comes with a guarantee, and in order to give guarantee, then you can imagine how much of work that you have to take place to remove all the uncertainties and then be able to say somebody else, give me money, I will come and prove it to you. Okay. That is one output guarantee. The second guarantee that they give is material usage. Important raw material consumptions are guaranteed. What does it mean? It is like what example can I say? Take a sulfuric acid plant, easier things, but the same thing is also true for complicated things. Sulfuric acid plant, the raw material most importantly required is sulfur, the rest is only air. Okay, so, let us leave the raw material air, sulfur. I said stoichiometrically if you calculate H2SO4S, it will come to 32 by 98, so 0.32 around that. That kind of a number the technology supplier will guarantee you, if you build the sulfuric acid plant based on my requirements, I will show it to you over a period of time, actually this is the amount of sulfur that is consumed and this is the amount of sulfuric acid that is produced. So, you get a hold on your cost. Remember, all this is because we talked about the variable cost, and in that there is an Excel sheet, all the raw material that goes in, amount of material consumed, unit price multiplied, that more or less becomes guaranteed to you. All you have to do is to buy only the raw material at the cheapest possible price. Okay. So, that is the third is, they also say that the product quality will meet the specifications what you have specified in the contract. Here again, if the guarantees are unmet, the same clauses, you have to rectify it and give it, and that's all. This is a big plus point. If you are a manufacturer setting up, why would you not give a important advantage to this? Is it not? It is not a matter that you should just laugh it and say okay, it is okay, but I will go for newly developing technology. So, everybody will look for these three things. EPCM company comes into the picture, how is that they have absorbed this technology from the technology company, so that they are in a position to get all this. They will also say wait a minute, I will give you one more guarantee, which is for a fixed price within that limit, I will also build you that plant. So, the manufacturer look at what all the security he gets it. He gets what is the money that he has to spend, that is a fixed number. It is like you buy a flat, if the flat owner says, but that is extra, you want this, but I never thought I will provide lighting for your house, that is extra. Oh, you want car parking, that is extra. Life is complicated. So, here it is guaranteed. So, you get guaranteed out money, and then the plant after it is built is also built to produce capacity, quality and at a cost. So, that is the reason why manufacturers generally prefer to purchase technology. One more plus point, which is sometimes what happens is this world is very competitive, right. So, you think you have bought some technology and then set it up, you are happily started it up running, you are selling and so on like that. Suddenly a legal notice may arrive, you have made that product, I hereby tell you that this technology belong to me and wrongfully you have used this technology and therefore I am suing you in this court, like that you can get a legal notice from somebody who claims that he is the correct owner of the technology, whereas you have gone to somebody else and signed it up with them. The clause also therefore accordingly provides indemnity against patent infringement. So, in case somebody future goes back and sues, this contract will say you just pass it on to us, we will take the liability, you are kept free. It is a big plus point, especially in this competitive world. If you are making a product, other fellows can always, competition can take any shape. So, you need some security, especially when large sums of money are involved in this. Last but not the least is, it is the shortest way to production, because you pay money, then whatever time it takes to construct the plant, it will take, maybe there will be a delay here and there. At the end of it, you will get output. This is the more or less like being clear about some predictability. Go back to my previous classes. In order to evaluate a project, I briefly said, and then I urged you to read up. I mentioned a word called discounted cash flow, right, DCF I used. What it meant was, you make some financial projections before the idea of setting up the plant. This is much before the idea of setting up a plant. Capital cost, variable cost, selling price, utilities, you would have made a lot of assumptions, and then on that you will give that, engineers will give that information to the finance person, and the finance person will make a massive Excel sheet where year 1, year 2, year 3, like that all the cash flows in and out, in that will come out. Then they will take a discounting factor, do the discounting, you will get either the internal rate of return, something called IRR, read up all this if you have time, or NPV, whatever. So, you will get this and then say, this project therefore seems to be worth investing, you would have decided. After you build and run, reality should be somewhat closer. You may not be bullseye, but you should be reasonably close, then only there is some security on that. In that, the shortest period of production comes, where it comes is, if we assume that it will take 3 years to build the plant, 4th year there will be so much of output, 5th year so much of output, like that we have made an assumption. What happened in reality, suppose you build the plant in 3 years, 4th year came, your original expectation was the plant will meet 65% of its rated capacity, because slowly plant start up. Suddenly you find it is producing only 20% of the capacity, land up in a problem. If you project that into that, the entire project might become viable, absolutely non-viable at all. That is the importance of doing it in time as specified. This DCF calculations, if you do, you will find the numbers. If the cash flows are delayed, you can get into very serious problem, and there are several companies, in spite of their best preparations, few of them have landed up in this kind of a problem, which finally resulted in the whole company being liquidated. Excellent companies otherwise, including yesterday I think some of you came, Mr. Stalin, he worked for a company called SPIC, brilliant record of 15 to 20 years that company had. Then they made one decision like this, and then did not turn out exactly what had happened. Then today it is not in the hot list, it is in some serious financial. So, for these reasons, companies, manufacturing companies buy technology. What is the lessons for the technology developer? Therefore, the technology developer should also ensure that whatever he is developing, he is in a position to meet all these requirements. That is the point, far different from what academic research takes place. Okay, here I mentioned briefly about infringement, and then I said it is like if somebody sues you and all that. What comes out is the technology developer immediately goes for a patent and establishes his ownership, because otherwise tomorrow anybody can claim it is mine, and where is the end point. So, there is a system of patenting which is aware, and just a few facts as it applies to India, which is what we will take. By and large, India is in line with international patent standard, small differences here and there, but nothing significant. So, this is an act, some of you might later on when you get time to Google read through that. First of all it says only inventions are patentable. First of all, what you can patent is only an invention, very clearly. Therefore, we should know what is an invention, and they have defined it in that act also, what is an invention. this is worthwhile memorizing and keeping it. I will read out therefore. Invention means a new product or process. In my earlier lessons I said what is technology means, if it is new it should be having something like that, it comes involving an inventive step and capable of industrial application. So, they have packed so many words, but it is a very important definition. So, new product or a process, it should have an inventive step and it should be capable of industrial application. Now, inventive step what also is defined, it says inventive step means a feature of an invention that involves technical advance as compared to the existing knowledge. So, it also says that nobody works in isolation in the world. So, you would begin with some level, as compared to that level there is an advance, technical advance which has economic significance, and this is not obvious to a person skilled in the art. This last word is a real googly, you have to remember. So, up to this is very clear. What is the meaning of that is something which is, let us say there is a heat exchanger, okay. So, you come out with this improvement to improve the heat transfer coefficient. What is the easiest way of doing an improvement of improving heat transfer coefficient? Can somebody answer? You have a heat exchanger, it has got a design heat transfer coefficient. You want to improve the design heat transfer coefficient. What is the easiest or the obvious way of doing it? Technically fins is yeah, if it is non-finned surface, if you fin it, surface area increase, heat duty will increase. Let us say bigger heat exchanger, I am saying heat transfer coefficient for the same size it can transfer more heat, that is a heat transfer coefficient. No? So, if you go back to the HDK is by experience found Reynolds number and Prandtl's number. So, if you have Reynolds number higher, in other words you introduce some turbulence, so that the finally in a film theory we have all gone about, na? Metal, this side there is one fluid, that side there is a fluid, heat transfer coefficient, fluid thickness, etc. So, if you improve the heat transfer coefficient by adjustment to the fluid mechanics at that place, whatever, fin being one of them, you can create other kind of a pattern surface or whatever you have, you can get higher heat transfer coefficient. But along with it what will come? Pressure drop. So, eventually what happens is you take a call of this versus that and take a design. Now, I come after some time to the patent office, I pick up your heat transfer equipment design and then do some tweaking like this, I create some pattern. I want to patent this heat exchanger, nobody can make this heat exchanger. For any person who is skilled in the art, he will say, sir, what have you done? Hey, what is new? I mean, you make a different, you get a higher pressure drop, in that curve it will fit in a different point. Hey, what is this? This is not patented, luckily. So, patent office very clearly, it is also manned with a lot of technically competent people in different forms and fields. They ensure that any patent application that comes meets a this is a test, it is a very rigorous test. So, in addition to that there are certain things which is not patentable, things like life forms, which is it there exists in nature, you can't do this. So, let us skip that, but summary is if you go for patenting, you have to be really convincing the patent authority that it is worth getting patented. Okay. If suppose you are successful, then theoretically is a very important word, theoretically you have a right that you only can be the manufacturer or seller of that idea or of the product for a period of 20 years. If somebody else wants to copy or do it, they have to come into an agreement with you, pay you whatever you are agreeing with them, and then they can make it. So, that is the patent office, which is funded by the government everywhere, does the service of guaranteeing some unique advantage to a innovator, provided they are satisfied, that is what it happens. Quick recap, if you see the 3 keywords, remember all this, but memorize this, this is very important, keep it in your career. But the keywords are, it is novel, non-obvious, that means a reasonable practitioner of the art cannot say, hey, what is this, that situation, if it is there 100% you can say it will not be patented, and it will also be useful. I have sometimes joked to people saying, I have got a brilliant idea, I am going to go and patent test. The idea is, I believe in Mars, there is a lot of hot gases containing sulfur is going around. So, all we have to go is there, go tap the gas, bring it back to India, convert it into some sulfur product, sell it. Anybody has thought of this idea? No, I will go and patent it. So, what is it should also be practically somewhat useful. So, this is something which is obvious, but on this endless controversies go through in patent office, legal fights and all take place. For our purposes, I will say, let us change it to not useful, because useful anybody can argue. Do you have an advantage to an existing customer? That is a much more practical way of, you must have all this, you are doing it for a customer, right, who will pay you and buy whatever. For his point of view, if there is a superior advantage, then your case is stronger. Okay. So, that is on patent. Obviously, there is a global patenting system, all countries work in cooperation with each other. In the past, each country used to take a slightly different approach. In fact, India was blamed in the 90s of not being in alignment with the world. It is all now gone. India is considered to be a very one of those well aligned with the international system. There is no complications, most of the people in the world feel while coming to India. In fact, they have even gone to China, which is much more opaque. Lots of people have gone to China, so why not in India? So that, but again, last point I want to say, we have to be watchful about the fact that simply getting an idea, like I gave the Mars and hydrogen sulfur example, is not worth taking patent, but I tell you, lot of people take like that. But technology is like in the earlier slide also, it is not simply a clever idea. A clever idea which is tested, tried in some scale, then you have the basics of a process flow diagram, you have a heat and mass balance, you have got some semblance of equipments that will go into making it like that, that qualifies for approach, and technology development companies do that. They also go and take some funny patents, okay, for some reason. Now, another thing about patents is, for all these complications we go through, most of the patents do not result in product or process. True. For example, there is a very nice site, United States Patent Office, Google that. It is a beautifully designed site. India Patent Office also got a site, but our site is somehow designed by somebody to make life miserable. But the US Patent Office site is customer friendly, I mean it's fantastic it is. So, you open that site and just see, put some keyword and then see how many patents are there. You will get something like minimum of 500, 600 patents, and then the patents are all serially numbered. So, I think we are running into some 100 million or so patents have been granted so far. How many of them, if you just take your sample of 300, 400, if you reflect for a minute, has any of them resulted in some useful stuff, product stuff that you can see? You would find that what I say is probably true. Therefore, the summary is, most of the patents, they do not land up in product or processes, and the patent is also made slightly expensive. This is a dilemma that the government has got. On the one hand, they want to encourage innovation, so they make it in the initial years cheaper to apply for it. If supposing say you have to pay 50,000 rupees for making a patent, the startups will struggle, right, every rupee counts. So, our patent system is also, initial filing of the patent etc. is very cheap, few thousands of rupees. But then they say that you can even provisionally put something else, say I am working on it, therefore I am taking a patent and come back. But subsequently, if you want to keep it alive till the time that the patent is actually examined and granted to you, they make it costlier. So, just like that, keeping patent for a smaller company etc. is very tough. Bigger companies on the other hand, for some reason which I will not get into, those of you who are interested can ask me separately, they do this funny game. Like otherwise, why there will be millions of patents in the US Patent Office, even though most of them are not converted, they do it for some other reason. Now, key point for chemical engineers, and especially those who are thinking of what a career in technology development is there is a huge amount of work that has to be done between getting an idea and therefore taking immediate patent cover, and actually converting it into a product or a service that is commercially viable. It is a huge amount of work. Of those demonstrated one, even fewer of them actually become successful, because you can even build a commercial plant. What is a commercial plant? Build a plant that works, right. That is the meaning of it. You build a plant, it works in terms of production capacity, whatever they get. But will the plant become successful? Meaning successful is in the market, you are able to sell it and realize money, that is no guarantee. So, this is the dilemma of technology development. Summary of this is, repeating the point again, but worth remembering, technology development is a very high risk area, long time, requires completely different set of mindset, not impossible, otherwise there will not be any technologies that we use today, right. All this have gone through that process, but that is what we have to keep it in. There is no short term gains in this. Global vision of what it is likely to happen is an absolute critical requirement. Keep this in mind. Why I underlined this, in the next slide you will come to know. You can't take a local problem and then get enamored with this, because time is limited, resources are limited, number of things that you can work is limited. So, we should avoid the temptation of jumping into an immediate problem and then saying that okay, let us go and get something there. You really need to have global vision, for the simple reason, if your idea really is successful and you are able to get a product, the world is your market, and the higher the market is, the better the chances of commercial success are, these days at least, because everywhere people are opening out. Like in the 90s I said, no, India made import sky high and developed local, all this is gone. So, everybody is kind of more or less on equal terms with everybody else. And in terms of personal requirement, this means those guys who decide to go to technology development, Donald Sadoway of MIT, they stay stuck in that field. There is no okay, maybe I should switch and go to this, that is better, maybe the growth is here and these fellows are giving me a higher promotion, etc. If your mindset is like that, then you would not enjoy this. So, that is what you have to make up your mind. Now, the underlying one, global vision, I said, and said I will come back to that. This is the connect. This is, all of us know Mr. Narayana Murthy, right. He is one of the, in fact he was the founder of, in some ways, Infosys, and lot of stories about how from moderate means and actually quite a lot. I am saying the man has, imagine a company which is globally known and done a lot, I mean there is no doubt. So, he was invited in Indian Institute of Science as a guest of honor for the convocation, and he was told speak, and from his heart I think he spoke. That thing is available in the net, you can read. I only took an extract from there. He said, is there one invention from India, one, that has become a household name in the globe? Is there one technology that has transformed the productivity of a global corporation? Is there one idea that has led to an earth shaking invention to delight global citizens? You can see this global comes 3 times. So, basically what he was saying in that meeting is, we are a large country, we have a lot of talent, that is no doubt about that, and we are probably what, 1/3, 1/4 of the world population ourselves. Why is that we are not having any world beating that sort of a, in probably anguish? I suppose he spoke more from like that, but it rose a huge controversy. Then people who were sitting in the audience, and there are some big time research guys who I can't name, they thought he is kind of passing a judgment on them. So, they got all their tails worked up. Now, who the hell is this guy coming and speaking about, after all what have you done? You have developed a software company. We are in basic science, we are in fundamental research, we are looking at nature in all its wonderful glory, and anyway you guys do not spend any money. When we want to come and ask you for funding for research, you become stingy. Who are you to like that? It went on. Now, my take of that was, the question is an excellent question. You can't, it is a fact. Did he make it up? No, you can't deny the fact. He did not make up some story, but I think he asked, or at least he raised it in the wrong audience. He knew he was going to Indian Institute of Science, and what do you expect in Indian Institute of Science? researchers, teachers, students, they are living happily their life. You go and create your anguish probably was. So, what we should have asked, that question should have been raised in forums like Confederation of Indian Industry, FICCI, where business people are present, and then they think, you do not have to answer, you have to think deeply probably. But so, last slide for the day, back to our immediate requirement. If you are thinking of a job in industry, that itself is a choice, you can go to any industry still. If you are thinking of joining an industry in chemical industry, you are better off by initially figuring it out in a manufacturing or a PCM, because there the rules of the game is fairly well defined. You are just out of college, so you can practice and hone your skills a little bit better. And of course, you are not going to, you may or you may not, like I landed up spending my lifetime on this, I liked it, but you may not, do not have to, you can anytime switch, but it is worth. That is what I think Mr. Stalin also said yesterday. Look for that, these two, make up your mind, plan right now onwards, and the rest of the course will also help you how to sharpen your skills to meet these two requirements. If you are still one of those guys, Mr. Srinivasan, have you heard about Apple, Steve Jobs? I am Steve Jobs. I will make a change, means I salute you, I wish you well. Okay. In the next class onwards, what we will do is to go back and then say, we have now understood this gory business of technology development and research and so on. So, from this onwards, there is a shift. All our management jargon we will stop, but keep that in the back of the mind. We are going to take up how to, from this idea to take it up to that level. So, which means first of all, what is this TRL? I told you there is a rough scale that people have been prepared, which can be used to judge a development. You bring some development, we can apply this concepts and say, oh, this is it. So, the TRL is a system of numbering. At the lowest level, it is TRL 1. Whatever is lowest, we will come to that. If it is super duper, it is, let us say, TRL 9. So, now our task is first to understand what is this commonly accepted TRL scales. Of course, there is, it is not rocket absolute precise, like I said, thermodynamic laws. It is just somebody has given some guidelines. So, let us understand the guidelines. You may have slightly different view, do not worry, but the range you get an idea. That is a scale, graded scale, low level, up level, high level. So, that we will first quickly understand, and then onwards we will take actual ideas which I am going to ask each one of you. I can give my ideas. In fact, I have a folder called promising ideas, which is growing. Whenever I read a research magazine or research output or talk to a researcher, I pick up that idea and put it up in my file. So, I have got a big thing. So, I can show it to you and then you can pick from there, or you yourself can come out, because based on your interest, some idea which you have heard about, we will take that idea, thoroughly discuss. If that idea has to be finally tomorrow built into a plant, how do we go about doing it? So, that is what is going to be the next couple of things. From now onwards, we are back to hardcore chemical engineering. Lot of views on Nusselts and Sherwood number and Schmidt number and Peclet number and all that will come. Okay.